Hi, okay, so here we're going to look at carboxylic acids. So carboxylic acids have the functional group COOH. And what you basically have at the end of a chain is a carbon, a double bond O, and an OH group attached to it. So when you name them, you look at the number of carbons, so you always include the one here with the carboxylic acid functional group. 1, 2, 3, so that's propanoic acid, prop being 3. Okay, this is always carbon 1 as well, so it's carbon 1, 2, 3, so that's why it's 3-ethyl hexanoic acid, this one. You wouldn't call it 1, 2, 3, 4, because you count from the side that has the functional group. That would be carbon number 1. This carbon here has the carboxylic acid group, so that's carbon number 1, takes priority. Okay. Right. Carboxylic acids are soluble in water because they can hydrogen bond to water molecules. So the lone pair on the oxygen, which is double bonded to the carbon, can have a hydrogen bond with an H there, and also the hydrogen here of the OH part of the carboxylic acid, that's delta positive, can hydrogen bond to the lone pair of the oxygen on the water molecule. Okay, so make sure when you draw your hydrogen bonds, you show them going from lone pair to delta positive hydrogens. As the chain gets longer, the carboxylic acids get less soluble because there's less hydrogen bonding occurring for the weight of the molecule. Propanoic acid, already. Okay, now we're looking at the reactions of carboxylic acids, and they just react like any other acid basically. So here we've got acid plus metal makes salt plus hydrogen, and we got the first one there, we've got ethanoic acid reacting with sodium, it makes a salt. The salt is sodium ethanoate. So this ion here, it's a negative ion, if you ignore the sodium for a minute, sodium ion, that's a carboxylate ion. This particular one's ethanoate because it's got 2 carbons, and because it reacts with sodium, we've got the sodium ion there, so it's sodium ethanoate. Notice we leave the charges on there to show it's ionic. And we're also producing half a mole of hydrogen gas. Next one there we've got is ethanoic acid again, this time reacting with magnesium. Now magnesium forms an ion with a 2+ charge. So to balance the charge, this ethanoate ions are only 1-, so we need 2 of those for every 1 magnesium ion. And that's how we could write it out there like that with the brackets, showing the charge, a little 2 there to show that there's 2 ethanoates for every 1 magnesium ion, making 1 mole of hydrogen gas. And this is called magnesium ethanoate, not magnesium diethanoate or anything like that. Okay, here we've got acid plus base makes salt plus water. So this one here is the simplest carboxylic acid you can get. Methanoic acid reacting with lithium hydroxide. We get lithium methanoate and water. And here we've got acid plus carbonate makes salt, carbon dioxide and water. The acid we've got here, done this in a skeletal form this time, it's got 1, 2, 3, 4 carbons, so that's butanoic acid, reacting with calcium carbonate. Again, calcium has a 2+ charge, so the calcium butanate that's made has 2 butanate ions for every calcium, so again the brackets and the little 2, you've got CO2 and water being produced.